Okay, now we're recording. Good morning, everyone. So we are doing something kind of new today. The whole algebra team is trying this new program called Easel. It's supposed to take a worksheet and then you can type on it and stuff. So the way that it's gonna go today is the Easel assignment or the worksheet thing we found has a couple pages of notes in the beginning that I'm gonna use and do notes on. And you're welcome to open up the Easel activity, which is lesson 5.4 in Google Classroom, and go along with me on the notes. And then there's 2 pages at the end of it that will be the homework problems. So you can go ahead and open it if you want to follow along and take your own notes, or you can just sit back and watch me take the notes. So I was going to show. So this is what it'll look like if you go into it. Mine, I'm doing it on Jamboard so that I can write, so it's not going to look the same. But this is what it will look like for you guys. So this is the first page, and then the second page, they're notes. So that's what I'm going to start with, and I'm going to be using Jamboard so that I can write on it. And you can use these tools to write, the pen and such. Oops. And you can write on here. But I just am doing it on Jamboard. That way I can save it for the kids that weren't here. Okay, so if you want to open it up, you can do that, or you can just sit back and relax. Okay, why did it just die on me? Oh no, hold on. Come back. I'm having technology issues today. Okay. So, what the heck? Why does this keep dying? Oh my goodness, what is going on today? It's cursed. Okay. Hold on. I'm going to try it one more time. Okay, I'm not going to touch anything. I'm going to let it do its thing. Okay. Can you see my screen? Someone tell me yes or unmute themselves. Okay.
Yeah.
So the first page of notes I kind of shrunk because mine is a little bit smaller, but it's the same page. I just moved up to the important part. Okay. So it says to graph the 2 lines. So I'm going to do that. So I have y equals 3/4 x plus 2 and 3/4 x minus 3. So my first line I'm going to do in red, and my second line I'm going to do in green. So I will start at 2, and then I'll go up 3 and over 4. 1, 2, 3, 1, 2, 3, 4. And there's my first line. Whoa, that was not on. Oh, well, you get the idea. Okay, and then my green one starts at -3 and goes up 3 over 4. 1, 2, 3, 1, 2, 3, 4. All right. So remember, if we go back to we're still in chapter 5, but if we go back to the first lesson where we graphed, the point of intersection is where these lines, what the answer was to the problem. So looking at this, is there a point of intersection? The question asks. Do these lines intersect? Remember, these lines will go on forever and ever and ever, but will they intersect? Meaning touch. No, they will not, because they are parallel lines. Does this linear system have a solution? No, because they will never cross. Okay, so we have these two lines that are going to go parallel forever and ever and ever and never touch. So they will never intersect or have a solution. Okay, now I'm going to do the second one. And I'm going to rewrite this equation, 2x plus 2y equals 6 minus 2x. Okay, and then the green one becomes y equals minus x plus 3. Okay, so now I'm going to graph these. I have minus x plus 3, so it'll start at 3. And then it's going to go down 1, over 1, down 1, over 1. And then my red line is the same exact line. It starts at 3, goes down 1, over 1, down 1, over 1. And connect the dots. So it says, is there a point of intersection? So do these lines touch or cross? Yes. At every point. And does this have a solution? Yes, it does. Every single point on this line is a solution. So 2, 1 is a solution. 1, 2 is a solution. 0, 3 is a solution. Negative 1, 4 is a solution. So every single point is a solution to this system because it's constantly touching. So remember, where they touch is the solution. Okay, moving on to the next. There's just a couple questions that I thought they were good ones. They kind of make you think and explain things, so we're going to answer them. So what are the 3 types of possible solutions for a system of linear inequalities? So if you remember all the way back to our Edpuzzle video for chapter 5, where it had the lightsabers and the Star Wars, they talked about the 3 solutions. So we have no solution, 1 solution, and then infinitely many solutions. So explain when each type of solution happens. So no solution is if they're parallel lines. One solution is if they're perpendicular lines. Or no, not perpendicular, but if they're just 2 lines that touch once. And then infinitely many solutions is when they're the same line. Do we have any questions about these? No solution, 1 solution, infinitely many solutions. This is what we're going to be doing on our homework assignment today. So any questions?
Nope.
Okay. So there's 2 more questions. Why do you think these are called special systems? So why are they called special systems of equations? Because it's rare that we have the same line or infinitely many solutions or no solution. It only happens occasionally and it's a unique situation. Okay, and then the last question says, what methods do you think you can use to solve special systems of equations? So if we go back, we used graphing. Do you think we can use substitution and elimination, or will they not work? Hint, they will work. So we can use all three methods. Okay, just one more page of notes. So this one, there's a few things to fill in. So with infinitely many solutions, or exactly one, excuse me, exactly one solution, we're going to have a coordinate pair as our answer. So it'll be x comma y. The slopes will be different. And the y-intercept can be the same or it can be different. So they can start at the same point, or they can start at different points and intersect at another spot. So examples are x equals -1 and y equals 1/2. A coordinate pair is our answer. And then I kind of had to cut it off, but you can see here they intersect at one point. Now we come over to infinitely many. The symbol is this fancy R, but when we're answering our homework today, you'll just put infinitely many. And then the slope, remember infinitely many is the same line. So they're going to have the same slope and the same y-intercept because they're going to start at the same spot and look the exact same. A true statement, 0 equals 0 and 4 equals 4. As you can see here, the graph, they're the same line. And then last up, we have no solution. It's a 0 with a slash through it for the solution or the symbol, or you can just write no solution. And then the slope will be the same because parallel lines have the same slope. But then the y-intercept will be different because they will start at different spots on the graph. So here one starts at 2 and the other starts at -2. They will go on forever, ever, ever, and never touch. And then this is just a good little sheet in your homework that has how to solve each type of problem. So if you get confused or forget, you can go back and look at this. So now we're going to come over here to easel, and it's in Google Classroom, you guys, 5.4. So go ahead and click on that. As you can see, here's the notes I just did. And then the 3 solutions, or the 3 types of methods. And then here's the homework. So the last 2 pages, page 4 and page 5, are your homework. So you're going to go in, and then there's text box right here, and you're going to put no solution or infinitely many or 1 solution. And so looking at these lines, the way I like to solve it is to first put both equations into a y= form to see if they're the same line. Because if they're the same line, it's going to be infinitely many. And it's kind of hard to tell that from looking at them in standard form. So I convert them to slope-intercept, so y = mx plus b. And then after that, you can come back to this and use substitution or elimination, or you can choose to graph them to figure out if there's 1 solution, no solution, or infinitely many. Questions 5, 6, 7, 8, it'd be good to look back at this page because it says solution has a system whose graphs have the same slope but different y-intercepts. So if we come back here, same slope but different y-intercepts, and have the filled out chart in our notes, the same slope but different y-intercepts would be no solution. So your answer for that one would be no solution. So that's what we're doing the rest of class, is working on this assignment. And so